Great. Well, thank you, everybody. Thanks for joining us today. This is your chance to ask us questions that you have on database cost optimizations. Some of you came in after the fireside chat we had on the same topic, and we promoted this Q&A session, but others may not have attended that fireside chat. It doesn't matter. Either way, you're all welcome. We're not assuming that you attended the fireside chat, so anything goes in terms of your questions. I'm your host today, and I have a couple of experts with me. And I'll tell you a bit about myself and then let them introduce themselves. I've been at AWS for a bit over a year. I have a background in various data-related roles across small companies, startups, big companies, and analytics and operational databases. I will not go into my entire history here. That's going to take a bit too long. But I will turn it over to the others to introduce themselves. Stephen, why don't you go for it? Tell us a bit about yourself.
Absolutely. Good morning, good afternoon, everybody. Glad to have you here. My name is Stephen Hans, and I've been with Amazon about a year and a half, maybe 2 years. Prior to that, I worked for a larger Wall Street company, big bank, for about 17 years. My experience is in databases. Worked as a database administrator for many, many years. But at Amazon, I specialize in a very specific NoSQL database, which is based on the Redis engine. One of them is called Elastic Cache, and the second one is called MemoryDB. And I will be glad to answer your question related to those two services. On to you, Vlad.
Oh, thanks, Stephen. Hi, everyone. I'm Vlad Vlaschano. I'm the worldwide tech leader for databases here at AWS. I've been with AWS for over 9 years now. I started a long, long time ago as a solutions architect, helping customers adopt our AWS services. Back then, we only had a handful of AWS services. Our portfolio certainly has grown ever since. I think we have over 200 now. And I gradually kind of focus more on our database services and help customers with Aurora, DynamoDB, and some of our other databases, and adopt them and use them in their architectures and in their solutions deployed on AWS.
Great. Thank you both. Please do ask your questions via the chat window. And while people are thinking of their questions, let's get started with a question for you, Vlad. So I'm new to the cloud journey, and I've gotten to the point where I'm self-managing my database on EC2 instances on AWS. What are some next steps that I would think of in terms of cost optimization in that scenario?
Sure. I think the problem with approaching that topic is asking myself first, why am I, or why are you self-hosting databases? What brought you to that point? Was it sort of a default kind of choice? Getting started, you're familiar with the managing your own infrastructure and stuff, and it just felt natural, or was it a specific reason why you were self-managing your databases? Because of certain features, certain controls that you wanted to have, certain specific application requirements. And that would be my starting point. It's important to understand why you're self-managing, so we can get you the best solution in terms of where you can go from there. A lot of customers, of course, that is their default choice. That's what they're used to, so that's where they start. And in that case, certainly kind of moving to a database engine that is managed by AWS is the natural next step. You get some efficiencies out of that, because self-managing your database takes a lot of resources, right? You have to manage your own upgrade cycles, backups, configurations, obviously kind of setup and deployment and all of those aspects. Whereas in AWS, with AWS managed database, a lot of that undifferentiated work is taken away from you, and AWS takes care of that. You certainly retain quite a bit of control over your databases, right? You get to decide when to do some of those activities. But the actual mechanics of doing that, you don't no longer have to worry about that. So that's one dimension on how customers are saving and optimizing their costs whenever they move to managed databases. But it is important to understand whether there's any reasons why you're actually on self-managed databases. Perhaps your application requires operating system level access to the database, or there are some, of course, scenarios where there might still be a need for you to run self-managed even today.
Yeah, so in many cases, and maybe perhaps even in most cases, it makes sense to move to a fully managed service. But you kind of have to examine, what the degree of control you want, and then decide on the basis of that if you want to continue with self-managed versus a fully managed database. So Stephen, just to get started here, a question for you based on your specialization. We've seen historically a lot of interest in caching from a performance standpoint for sort of response time and low latency benefits. What's the cost optimization angle with respect to caching?
Thank you. Yeah, that's a good question, and it's a major theme this year. Cost optimization. Everybody obviously would like to save money on their services, and we do listen to our customers and pay attention to them and try to provide the best services at the best price point. So when it comes to caching, you have to examine when caching is applicable to your workload. So a caching service is applicable to a workload that is read heavy. So meaning that you have repetitive read queries or repetitive read requests. It doesn't have to be a query because, for example, the Amazon Elastic Cache service can be used to cache any kind of data. It doesn't have to be coming out from a relational database. But as long as you have repetitive reads, a caching service could boost those workloads. So when it comes to cost optimization, one of the advantage of using Elastic Cache is that there's no I/O charge for it. So you load the data once, and you could read it as many times as you want without incurring additional I/O charges. You pay a flat fee, a per instance fee, and then you pick the instance size that best fits your workload, and that's your fixed cost. So at least from that perspective, it's a very advantageous. The second one, it's a performance. Similar performance if the workload requires a really high read throughput, when we're talking about sub-millisecond in case of Elastic Cache. In many cases, to meet that demand, and talking about millions of transactions per second, you would have to really scale up whatever your source of truth that is, whether it's a database or some other source. That will probably come at a great expense. So in that aspect, again, a caching service is a good cost-saving solution.
Cool. So a question for you, Stephen. What is the crossover point in terms of read versus write workload at which caching starts to make sense? Absolutely.
That's a good question. So we recommend that the read versus write ratio to be above 70%. It is starting to be cost beneficial at anything above 50, but the savings may not be that substantial. But once you're in the 70-30 range, the savings are going to be, and the performance difference is going to be substantial. So that's kind of like the magic number. If you have a workload that's mostly read, but again, about 70% read versus write, then it's really a good solution.
Yep. Stephen, your audio went out. In fact, I'm frozen too, so I'm not sure what's happening.
I heard you really well, so let me repeat my answer. So the question was, what's the read-write ratio when a caching service becomes beneficial? And it's at 70%. Our studies have shown that any read-write ratio above 70%, it's starting to benefit significantly by adding a caching service. It will benefit even above 50%, but the savings may not be as significant. But once you move past or close to the 70% read-write ratio, a caching service will be a significantly cost-saving solution.
Okay, cool. So another question. What are the infrastructure considerations in terms of cost optimization?
So yes, absolutely. High availability and cost optimization, it's very important at Amazon, probably second to security. And there are a lot of options available there from the infrastructure perspective. So again, it depends on the workload and the specific customer's comfort level. But yes, we do offer multi-AZ capabilities, and we do offer dozens of various instance types that the user could select from that is best suited for the workload. So you're not either over-provisioned or under-provisioned. In addition to that, we do offer reserved instances, and earlier this year was introduced a third type of instance, something called a data tiering instance, which allows you to split the work, if you could think of it, in three layers. You could think of it as a caching layer, as a hot data, which has to have really fast access to it. That's your hot data, and data that's on a traditional database, you could consider that as cold data because access might be a little bit slower to that. With this newly introduced instance type called data tiering, you have a third layer sort of in between, a warm data. And we offer that at a really good price point. So customers could realize about 60% cost savings if they elect a data tiering instance.
Okay. So same question for you, Vlad, in terms of the other database services. What are the selections of instance types and instance classes and sizes? Can you speak to that in terms of cost optimization?
Absolutely. Of course, we have different database services, and they all work slightly differently. Some are what we call fixed compute based, or rather, kind of discrete compute based, where you have instances where you can select sizes and instance types. We have some services that are actually serverless, where you don't interact with discrete instances, but you set capacity and you set the level of utilization in different ways. But fundamentally, it's about your utilization and how much you utilize your databases. The idea is that you can scale those instances up and down over time, so you don't necessarily have to provision for peak all the time and have a lot of underutilized capacity. And as far as instance types and instance sizes, we also offer reserved instances as an option, so you can make long-term commitments to using certain instance types or certain amounts of capacity in exchange for savings of up to 66%, 67%, depending, of course, on the instance type and class. So there's quite a couple of different parameters that you can use to align your actual needs and utilization with the best cost optimization strategy.
A question just came in. Let me read it out for you. We are using RDS Aurora, MySQL compatible, in several AWS accounts that we use to host our application. We have started to move some of our environments to serverless. Does or will AWS be offering something like reservations, which will offer a discounted rate if we commit to a certain number of ACU hours? You touched upon this a bit. Would you anything else to add to the answer here? That's for you, Vlad.
Sure. So we're always looking at ways to help customers and optimize their workloads as best as possible. Right now, if your capacity is predictable today, to the extent that you know whenever your peaks are going to be, and you know when your workload's operating at a lower capacity level, provision capacity is still going to be the most cost-effective option for you. Really, where serverless helps you most is going to be in a situation where you have unpredictable variability, and that variability can be quite dramatic between, let's say, your low points of utilization and your high points of utilization. this time I can't share anything as far as future plans in terms of other pricing options for some of those services. But we're certainly exploring, we're certainly listening to customer feedback, and we'll provide that to the service team in terms of what sort of options our customers are also looking for in addition to what we have offered today.
Cool. It looks like we have another question here. Yeah, so with regards to following up on that, Vlad, how easy is it for me to switch my instance type and class based on various considerations related to workload?
So it depends, of course, on the database service, right? But let's follow through that example that we had before with Aurora MySQL, for example. Aurora is a cluster-based cloud-native database service. So switching capacity in the least disruptive way for your workload with the minimum amount of downtime would involve what we call a failover. So you basically provision a reader in that cluster or read replica that is the right size that you would like, and then fail over your current workload to that. So that would result in typically less than 30 seconds of downtime. And it's a really fast operation in most cases. And you can adjust the capacity on an ongoing basis. And that applies, of course, with serverless version 2 as well, because you can actually have Aurora clusters that have a mix of capacity modes. So you can have, for example, a writer that is serverless and readers that are provisioned, or you can have readers that are serverless and a writer provisioned, or you can have an entire cluster that is serverless or an entire cluster that is provisioned. And you can even switch between those capacity modes, right, over time. For example, you have a period of time, e-commerce applications are a great example. You may have a period of very, very high utilization around the holidays here in the US. Thanksgiving, Black Friday, Cyber Monday, going into Christmas, and so on. You may wish at those times to actually have provision capacity at the very high utilization rate, but then on the rest of the year, you might be okay with serverless capacity because your utilization may be lower or maybe less predictable. And you can mix and match that way as well as needed. Now, that of course works for for Aurora and some other database engines. You only have to, especially with RDS, you have to contend with purely working with instance types and using failovers as a way to kind of scale them up or down in the least disruptive way. And then there's, of course, services like DynamoDB where you can adjust the capacity, the read and write capacity units that you are consuming as needed, right? There's even auto-scaling capabilities. DynamoDB also has an on-demand capacity mode where you pay for what you actually use. So the way you would scale up and down, of course, depends on the service, but typically you can accomplish any sort of kind of capacity scaling with minimal disruptions, if any at all, depending on your service that you're using.
Great. Okay. I think this one is for you, Stephen. Does it make sense to cache all of my application data?
Good question. Probably not. No. Caching all of your application data would basically double your footprint to begin with. And secondly, it's going to put you in a position to validate all that cache. So it's probably not a good idea to cache all of your data. You only want to cache actively used data, quote unquote, hot data. From one of them is a cost perspective, and another one management perspective. Yes, it's not that's advisable. And Elastic Cache offers you multiple ways to do that. You could set up, for example, a TTL, a time to live per key. So you could set your data that would be automatically expired. So you don't have to expire it. That's one way to do it. Another one, you could implement something called a write-through cache that when the database is updated, you would update the cache as well accordingly, only for the data that you deem it necessary to be cached. So you have a couple of options there, but it's not recommended to cache the entire data set. No.
Cool. This one is probably one that both of you can weigh in on. How do I decide between adding read replicas versus adding a cache?
I think, kind of Steve mentioned it at the beginning. The key there is repeatability of the queries, right? To the extent you're accessing data that is the same one or more or less the same one over and over again. So you're querying for the same data sets, or perhaps you have fast moving data where it gets updated quickly, but it's more transit in nature, for example, leaderboards in games and so on. Then caching is likely going to be your better solution there. Now, if you need read scalability, but your data and your queries tend to access different data, right, where you don't necessarily have that body of hot data that keeps getting accessed over and over again, then read replicas are most likely going to be a better solution for you. Okay. Because they would give you the ability to kind of query your entire data set, but it gives you more throughput and more capacity to service those queries.
Okay.
Steve, what do you think?
No, I agree with you. Absolutely. If the nature of your queries are ad hoc and the access patterns are not known ahead of the time, then read replicas would be your best friend, best solutions, because that's what the relational database will help you with. On the other hand, if the access patterns are more predictable and the workload is something that has a repetition factor to it, then a caching service is the better solution. So again, depending on the workload, then you have to select the best answer to that.
Yeah. So it's on the temperature of the data and centrality of access and those sorts of considerations. There's a follow-up question here. What are the cost implications of adding read replicas? And I think either one of you could take that one. Go for it, Vlad.
So for databases that are certainly instance-based, like Amazon RDS or Amazon Aurora and DocumentDB and Neptune, certainly you add read replicas, those are going to be additional database instances, right? Whether those are serverless in or they are provisioned. So your cost is going to be determined by the number of instances and the instance type that you're using for those read replicas. And that you would have with cloud-native databases like Aurora, DocumentDB, or Neptune is that the storage is actually shared. So you're not paying for storage duplication, you're only paying for the compute instance costs. Whereas in RDS, in classic RDS, replication is based on logical replication. So each instance would need to have its own dedicated storage and copy of that data. So there are some trade-offs, of course, between something like an Aurora and an RDS in that scenario with read replicas. And that might affect which one of those would be cost-effective, especially if you're looking at comparing, for example, RDS MySQL with Aurora MySQL, or RDS PostgreSQL with Aurora PostgreSQL. But by and large, you're looking at the duplication of factor on the cost of your database instances. So if you have 2 replicas, then you of course would pay for the twice the compute capacity, 3 replicas, and so on. And the size, of course.
Mm-hmm. So your cost would scale accordingly in terms of the replicas. The infrastructure cost would scale accordingly in terms of replicas. Cool. Does the selection of region and availability zones impact my cost?
Yes, it does. There's certainly regions where the compute costs are lower, and there's certainly regions that our compute costs are higher. The way you can think about it is where our cost for operating our data centers and our infrastructure is lower, then we can extend those savings to customers. And where those costs are higher, then costs are going to be slightly higher. there is variability between the regions. So from a workload perspective, customers should look at what matters more to them, right? There's certain workloads that have to have data stored within certain regions, right? For data sovereignty reasons and for other reasons of being close to their end users, honestly. And there are some workloads that tolerate more of a region selection based on purely on cost, where latency may not be necessarily quite as a significant.
Okay. Anything to add to that, Stephen?
Absolutely. The same thing applies to Elasticache as well. Elasticache, the service is available in every region where we offer services, but the pricing is going to reflect the local pricing. So it may be different from region to region. In all the cases, similar to a database service, a caching service can add actually you can add read replicas to a cache itself to scale up or scale down your throughput. Adding multiple read replicas doesn't make the cache any bigger, but it does allow for even faster throughput. You could distribute the reads instead of reading from a single caching service, you could read from multiple caching services. So again, if you had multiple of those, definitely your capacity is going to stay the same, but your capability of delivering more data is going to increase, and that obviously comes at the cost. The difference is that you just pay per instance fee. So if you want to add 2 read replicas, you pay 2x for those 2 extra instances. Other than that, it's pretty much the same. There's no difference. Now, some versions, if you install Elasticache, the newer versions with something called the cluster mode enabled, they do support auto scaling. So if you have workloads that are not predictable, then the auto scaling would be a good factor that would scale automatically as needed per workload. Or if you have a very predictable workload, you could even set a specific capacity for a future date. So as Vlad mentioned, that if you anticipate a large demand for an anticipated event, maybe a Black Friday or some similar sales promotion is happening, you could scale for a specific future date to meet that demand and then scale back down. Auto scaling would be a reactionary approach, and a time-based scaling would be a pre-anticipated scaling. So that can be done as well.
Okay. Let's see. There's a question here about do your database services support Graviton processors, and what sort of cost benefits can I see there? Oops, I think, Stephen, you're still talking.
Okay. Yes, absolutely. We do support Graviton, and Graviton usually offers you a better price performance return than any other platform out there. In addition to that, the Graviton-based instances offer an encrypted memory as well. So security is number one responsibility here at Amazon, is job number one. So we do support the traditional encryption at rest, encryption in transit, but on the Graviton instances, we also offer the encrypted memory as well. So if your industry is one of those that it's highly regulated, or maybe the government industry, or some other industry that requires that level of security, then we do offer that as well. So you not only get the additional cost performance benefit on a Graviton instance, but you also get the additional security benefits.
Okay. Anything to add there, Vlad?
Yeah, similar to Steve's answer, our database services that are instance-based, most of them are going to support Graviton instances as well. I would call out that there is actually technically 3 generations of Graviton instances, Graviton 1, 2, and 3. Most of our database services will support Graviton 2 instances, and some of our cloud-native database services like Aurora, for example, support also Graviton 3 instances. What we've seen is typically for relational databases, you will see anywhere between a 20 to 40% price performance benefit by going with Graviton instances, especially Graviton 3 instances, compared to the more traditional x86 architectures. Now, of course, every workload is different, so the savings that you might experience may be different in a different workload. So we definitely recommend you do your own testing and see what sort of optimizations you can achieve.
That's great. So Gina wants to know, we are starting to look to move our clients' data into the cloud. It's about 550 gigabytes of data, looking at both EC2 and SQL Server versus RDS SQL Server services. It seems that pricing is vastly different based on the pricing calculator. Could you please explain the difference, pros, cons of the two services? So comparing and contrasting EC2 with SQL Server versus RDS SQL Server services.
Sure. So when you're running, of course, with your EC2 SQL Server and EC2, you do have the option to use a larger set of instance types and instance sizes, whereas in RDS, the instance types and instance sizes are somewhat more restricted. Only certain types and certain sizes are available. So if you're, I would make sure first that you're comparing apples to apples, right? But when you think about the cost of operating your database, it's not just purely about the price per hour of the database, of the compute, or even the storage for that matter. It's the time you spend managing those systems over time. So, your investments in people, in additional supporting infrastructure, automation, additional tooling for backups, monitoring, and so on and so forth, that you also need to factor into the cost of those, into the total cost of your databases. And what we find often is when we're talking to customers and we're seeing we're adding all of those costs together over time, over a span of 1, 3, 5 years, the lifetime of essentially some of those decisions. We find that going with RDS is going to be a more cost-effective option over the long term, especially factoring those other costs. So it's not just looking at the cost per hour of an EC2 instance versus an RDS instance. It's more than that to be factored in.
If I could expand a little bit on the Graviton question, the Graviton processor, in addition to giving you a really good cost performance option as well, it's also one of our champions in sustainability. So many companies are really sensitive about sustainability and are lowering the carbon footprint. The Graviton architecture offers you the best of that world and has the smallest carbon footprint. So again, it may not be important to everybody, but if that's one of your corporation's agenda, quote unquote, saving the planet, then using the Graviton architecture is going to help you in that direction.
Okay, cool. What are the instance size and instance class considerations related to I/O intensive workloads?
Certainly, when you're choosing an instance size, there's really 3 kind of main components you have to look at, or actually 4. The instance size is going to come with a certain amount of compute capacity in terms of vCPUs. The instance will also come with a certain amount of memory. And the third and fourth aspects of that, certain instances are going to come with certain amounts of network throughput, network bandwidth, and certain amounts of EBS optimized bandwidth. So our instances, typically you can envision them having two channels, right? One is for traditional client server network traffic. The other channel is for IEO traffic to block storage like EBS. So those two latter dimensions in terms of what an instance provides would matter most for IO-intensive workloads, especially the EBS optimized bandwidth that a specific instance type would provide, because that essentially is the ceiling on how much IO you can push through to the instance. And it doesn't matter how much storage and how much IOPS you provision for the storage, a certain instance can never exceed its own EBS optimized bandwidth. So, so that would be one of the aspects that you would have to look at from an instance perspective. Now, if you're building a system that is for IO heavy workloads, the other aspect of it would be the type of storage and the configuration, the parameters of that storage. So in our managed databases like RDS, we typically offer general purpose storage, and we offer what we call IO optimized storage. Those two storage types are designed for the different types of workloads. So if your workloads are consuming and need high IO, and they need predictability as far as how consistent that high IO can be delivered, then IO optimized storage would be the best solution. IO2 is the storage type in that case. Now, that's if you're using instances with EBS block storage. For some of our cloud native databases like Aurora, they don't use EBS type block storage for their persistent storage. Aurora uses a purpose-built distributed log structured storage engine that is shared across all of the nodes in that particular cluster. Now, for those instances, the EBS optimized throughput of the instance size matters less, and the network throughput on the network channel matters more, because all of the traffic to that dedicated storage service is going to go over the network throughput. There's also a consideration for temporary storage. So in an Aurora environment, Aurora instances do have some locally attached storage that is provided by EBS. And if your workloads are IO heavy, but are IO heavy for temporary tables or temporary files, like sort files, for example, then you would also want to provision an instance that has sufficient temporary storage to sustain that amount of throughput. So in summary, two storage types typically available in RDS, IO optimized, where you can actually specify the amount of throughput that you want and the amount of storage you want, and and AWS will deliver that capacity on a consistent basis. Or general purpose storage, which has a cheaper price point. With the general purpose version 3, you can actually specify how much IO capacity you want as well. But we make less commitments in terms of consistency of us being able to deliver that level of performance on a consistent basis.
So we go ahead.
No, go ahead.
Oh, you blipped out, so I wasn't sure whether. Okay, we announced some IO optimized class and instance sizes, etc., to make the choice easier, right? Are those, is that instance class available across all of our database services?
So IO optimized is a feature of Aurora today, and what that means is the IO optimized storage provides two advantages. One is in terms of performance. The other one is in terms of cost predictability. In a traditional Aurora environment, you would pay for the compute capacity, you would pay for the storage you consume, and you would pay for the amount of IO you consume. A lot of customers, it's really hard for them to predict how much I/O they're going to consume, right? Every database is different. How the queries that you're making translate into I/O operation is not quite as deterministic, so it's hard for customers to predict that. With I/O optimized storage, customers no longer have to pay for that I/O dimension, on an on-demand basis. The cost of I/O is rolled both into the cost of the compute as well as the storage. So you would pay for a higher per instance hour cost as well as a slightly higher storage per gigabyte rate, but you no longer have to pay for that third dimension. So it gives you a dimension of cost predictability, and that's great for workloads where we found it's more cost effective for workloads where in a traditional Aurora cluster, in a classic Aurora cluster configuration, they would spend more than 25% of their total Aurora cost on I/O. So if you're above that threshold, then I/O optimized is going to be more cost effective than a classic Aurora cost model. Now, the other advantage you would get with I/O optimized in Aurora would be some performance enhancements and lower I/O latencies. We can more easily implement over time I/O optimizations and different optimizations that if we were to implement in a traditional Aurora cluster, that would impact the amount of I/O that a specific database would generate. So we can make certain trade-offs and give you better performance, lower I/O latencies in I/O optimized without impacting your cost in I/O optimized, which is another advantage that you would get from I/O optimized storage. So there are both performance optimizations as well as the cost predictability that you gain when you're using I/O optimized storage in Aurora.
Okay. And you mentioned that the crossover point is 25% of your bill coming from I/O. Is the time that it makes sense to sort of look at the I/O optimized instances?
Right.
Cool. Okay, there is a question here from Jerry. Are there recommendations for a logging database with massive data that is 95% right, but still requires search capabilities?
Certainly. I mean, it depends. It depends on the nature of the workload, right? The thing with logging databases that we find is that most often a lot of that data is cold, right? So a lot of the searches are ad hoc, and most of the time what we also find in those types of databases is that a huge percentage of that data is directed only on the most recent data, right? The most recent slice of time. So I would look at, what is the time dimension for your queries and how much of your queries spent all over that spectrum of time of your logs versus how much of your queries are focused predominantly on the latest data, last day, last month, last week, whatever that time factor is. And based on that, I would recommend building a tiered solution where perhaps your older logs are stored in something like Amazon S3, and you could query them with an ad hoc tool like Amazon Athena for those few queries that, go for a very, very large period of time in the past, right? But they're comparatively infrequent. And I would store the data set that is more commonly queried in a database, right? That is more tuned to that workload. Now, it of course depends also on your queries. If the data is highly structured, then potentially a relational database might be a good fit. If the data is less structured, right, then potentially something like OpenSearch service might be a good solution, which is a search optimized database and an analytics platform built in. I don't know if you're familiar with it, if you've heard the concept of an ELK stack, Elasticsearch, Logstash, and Kibana stack, OpenSearch would provide you that capability built in. But ultimately, there's going to be a cost effectiveness factor on how much data you're storing in that online database versus how much data you can accumulate in something like S3 for data that is less frequently queried. And then caching comes into play there as well. If you're having some very, very hot aspects of your data, right? The last day of your logs, let's say, that gets highly, very frequently queried, caching can come into play there as well as another tier, right? In terms of the retrieval speed of your data. Yeah. The thing you would want to avoid in the long term is, right, in a relational database like Postgres or MySQL, you don't want those tables to grow indefinitely, right? That's one thing that we often find with current implementation, with current customer solution for logging. They just basically, customers stick the log data simply into a log table, right, in the same database where their primary workloads are. And that sooner or later is going to cause problems, right? Both because of the size of those tables that get accumulated uncontrollably, as well as the compute cost of accessing those tables, taking away from the available bandwidth for their, critical workloads. So that's something that we'd like to avoid, right? Either by putting a time limit on how much data gets accumulated in your transactional databases, regardless which one it is. And there's, of course, a cost aspect to it. Storage, no matter how you look at it, storage on a transactional database is going to be more expensive than storage of cold data in S3. So if the data isn't accessed frequently, it'll be more expensive storage in a database than it would be in S3 and queried ad hoc with a tool like Athena.
Okay. We are quickly approaching the end of our allocated time. It went by so quickly. So Vlad, I just want you to say a bit about the tooling that we offer for understanding your cost drivers and where should you be looking to optimize your costs. What are the things that we offer for people to understand cost profile?
So there are a number of tools available, and they cater to different use cases as well, right? The Cost Explorer tool in the AWS console would be the tool that you can use to get a big bird's eye view of your cost. Where your cost is going to, you can also slice that data based on what we call cost allocation tags, where you can allocate different tags to different workloads, different resources, and then that cost can be aggregated against those tags. So you can, for example, kind of separate out the cost of your, let's say, production workloads versus your development workload, and assess the costs in those costs individually. It gives you a nice visual way of interacting with your cost data at again, more aggregated level. There's also a tool called the Cost and Usage Reports, which gives you the raw data of cost essentially in a tabular format that you can then use with third-party tools or with your own in-house built tools to build automations around those costs and monitoring those pieces of cost. But again, it's going to be also a more aggregated level. And then the third kind of dimension on that is the monitoring tools offered by the databases themselves, right? A database, for example, like Aurora will have metrics exposing, the amount of storage consumed, the capacity, ACUs for serverless. So you can in more real time, understand better the costs of that particular resource, and build automations around that. For example, if a cost exceeds a certain amount for your compute capacity for your database, or for example, for storage capacity, then you can build automations around that and notifications and so on. So it really depends on how granular you want to go and you need to go. But we offer tools sort of that span that spectrum from aggregated views all the way down to the individual instances and the databases themselves.
Great. So there's a lot of tooling and transparency around what's driving costs, and it's not hard to understand where you should pay attention in terms of cost optimization. So Stephen, for you, I would imagine a lot of people are, have questions about availability, given that ElastiCache is in memory. Does ElastiCache provide HA?
Yes, a very, very good question, and often comes up. Yes, ElastiCache does offer multiple HA capabilities. At the very least, I mentioned earlier, it does offer multiple read replicas, and those read replicas can be distributed within a region to multiple availability zones. And not only that, which obviously protects you from on specified outages in an availability zone, but we offer automatic monitoring, fault detection, and automatic recovery as well. So this is within the region. If the customer is interested in even on a larger scope, we do offer actually cross-region replication as well. This is in an active passive way. So you can have a primary cluster in one region in read-write mode and have up to 2 clusters in 2 additional regions in read-only mode where you could replicate your data. So this is a great tool exactly for that, for high availability and to move the data closer to your client, even at the region level, only the hot data that's required. So those are offerings there. These all actually come at no extra charge. High availability does not carry an extra charge. Of course, the instance does, but for example, the service global data store comes at no extra charge.
Okay, so we are at time. I could keep going. There's plenty to talk about here, but we've reached the end of our allocated time. Thank you guys very much, Steve and Vlad, for your contribution here. Your expertise is really valuable. I would love to come back and have more conversations with you on this topic and other topics related to data. So thank you for our attendees. And I think, it's a wrap.